Ever wondered what lies beyond the realm of real numbers? Welcome to the fascinating world of complex numbers. Now you might be thinking, complex numbers? That sounds intimidating. But fear not, they're not as complicated as they may seem. Let's start with the basics. Picture the real numbers you're already familiar with, but now, imagine that we're expanding this system to include something a bit more complex. This is where our new friends, the complex numbers, come into play. A complex number is simply a combination of a real part and an imaginary part. It's like having a duo of numbers working together to create something extraordinary. Now, this imaginary part isn't as fantastical as it sounds. It's defined by the imaginary unit I, which is, believe it or not, the square root of -1. So, complex numbers are not as complex as they sound. They are merely numbers with a real and an imaginary part. Now that you know what a complex number is, it's time to delve deeper into its components, the real and imaginary parts. Think of a complex number as a two-part story. The first part, the real part, is familiar to everyone. It's a regular number like 2, 5, or -7. It's the kind of number you'd use to count apples or measure the length of a table. The second part of our story, the imaginary part, is a little more mysterious. It's a number that's multiplied by a special symbol, I, which we call the imaginary unit. You might see something like 4i or -3i. If you're wondering where this I comes from, it's defined as the square root of -1, a number that doesn't exist in the realm of real numbers. So we have these complex numbers made up of a real part and an imaginary part. But how do we visualize them? Imagine a plane. The horizontal axis, the x-axis, represents the real part, while the vertical axis, the y-axis, represents the imaginary part. Each complex number is a point on this plane, just like how each city on a map has its own unique set of coordinates. Just like coordinates on a map, the real and imaginary parts help us locate complex numbers in a plane. Complex numbers are not just for show. They can be added, subtracted, multiplied, and divided, just like real numbers. Now let's dive into the world of operations with complex numbers. When you're dealing with these, the letter I is more than just a letter. It's an essential player. And its most important rule? Squared. It equals -1. So, how do we perform basic arithmetic operations with complex numbers? It's simpler than you might think. Let's start with addition. If you have two complex numbers, say 3 plus 4i and 2 plus 5i, you add the real parts together and the imaginary parts together. So you'd end up with 5 plus 9i. Subtraction works the same way. You subtract the real parts and the imaginary parts separately. Multiplication is a bit more interesting. When multiplying complex numbers, you need to apply the distributive property just like you would with algebraic expressions. And remember that I squared equals -1. Division might seem tricky, but it's not so bad once you get the hang of it. The trick is to multiply the numerator and the denominator by the conjugate of the denominator. This gets rid of the I in the denominator, making it a real number. Remember, the rules of arithmetic still apply, but with an imaginary twist. Complex numbers may seem abstract, but they have concrete applications in real life. Imagine a world where we can handle quantities that exist in 2 dimensions, not just one. This is the realm of complex numbers, an essential tool in many scientific fields. In electrical engineering, for instance, complex numbers are invaluable. They're used to analyze AC circuits, representing voltage and current as a combination of magnitude and phase. This allows engineers to solve problems that would be impossible to tackle with real numbers alone. Physics, too, relies heavily on complex numbers. Quantum mechanics, the study of particles at the atomic and subatomic level, uses complex numbers to describe the state of a system. This mathematical language allows physicists to predict how particles will behave, unlocking the secrets of the universe. Complex numbers also find their place in computer graphics and signal processing, offering solutions to problems that require the manipulation of 2-dimensional quantities. So, complex numbers, once understood, can be a powerful tool in solving real-world problems. In just a few minutes, you have journeyed from the basics to some real-world applications of complex numbers. We've unpacked the structure of these intriguing numbers, delved into their real and imaginary parts, and mastered operations with them. We've even glimpsed how they shape our 3D world. The world of complex numbers is vast and fascinating, and you've just taken your first step into it. Keep exploring, and remember, understanding complex numbers can make your mathematical journey a lot more interesting.